All right, so let's start our class. So first of all, let's review what we learned last time. Last time we talked about what is electrolytes, and we did in the lab also talk about the electrolytes or conductivity. So electrolytes, first of all, they have to have those following two parameter properties to be electrolytes. First of all, they must be able to dissolve in the water. They have to be soluble in the water. Okay, they have to be soluble in the water. Secondly, they can transfer electricity or conduct electricity. Okay, so last time we did the lab, we test the solids, liquid, solution, and try to figure out, okay, which one has a conductivity. Okay, so you did the sodium, you know, solid sodium chloride. I mean, there's no conductivity, cannot conduct electricity. Okay, that's because this guy is a solid. There's no ions can transfer the electricity. But if you're adding the water in there, it will, and has a really good conductivity. Okay, so electrolytes is generally we talk about the solution that containing ions over there. And we know sodium chloride, the solid sodium chloride is solid, but when they dissolve in the water, it become ions, so they can transfer electricity. But some other compounds like sugar, and especially for the organic matters, even this organic matter can be dissolved in the water, but they are not going to become ions. They will be intact in the water. So still, they're not going to conduct electricity. Okay, so sugar, this kind of things, when they dissolve in the water, although it's dissolved in the water, but it still cannot transfer electricity. So we call this kind as called non-electrolytes. And we talk about what happens when the sodium chloride dissolves in the water. Sodium chloride, when it dissolves in water, and there's no more sodium chloride, you see? When they dissolve in water, there's no more sodium chloride solids. Instead, they become a sodium ions and the chloride ions. And those are ions, the cations and anions that are making the sodium chloride compound. Okay, but when they dissolve in the water actually is pulling those ions, the cations and anions apart. Okay, so they separate those apart, become ions in the solution. So that is why they can transfer electricity, because electricity also has a charge. Okay, so they have to, when the electricity travel, they have to combine some kind of another ions, the cations, so to travel. Otherwise, the electricity still cannot be travel in the solution. Okay, so this is a very, very important concept, as the electrolytes, when they dissolve in the water, they are not going to be no more electrolyte, no more this original compound. Instead, they become a cations and anions. This is a very, very important concept. Okay, yeah. Yeah, so just like the sodium chloride, the solids is no more solids. Instead, I think I should write it's not solids. When the sodium chloride is dissolved in the water, they're going to become sodium ions and also chloride ions that dissolve in the water. This is a very important. And we also talk about what is the strong electrolytes, what is the weak electrolytes. And also we did the lab we talk about what is a strong electrolyte, what's the weak. Strong electrolytes, usually they can conduct electricity very well. The weak electrolytes is they can conduct electricity, but not very strong, okay? But non-electrolytes, there's no possible to transfer electricity, okay? So pure water generally is a non-electrolyzed. Pure water cannot transfer electricity, okay? If you see the deionized water can conduct electricity, that's probably because the pure deionized water is not pure anymore. And the last time we also talked about two different chemical reactions. One reaction is called the precipitation reactions, right? We talk about the precipitation reaction is part of the double displacement reactions. So we have the two ionic compounds, and then when they two ionic compound in solution, this is important. Two ionic compound in solution, and those two clear solution, mix them together, and we have a precipitate coming out. And the reason is precipitate is because this kind of the compounds cannot dissolve in the water anymore, and they are coming out of the solution. They are coming out of the solutions. Okay, so one of those products is insoluble, so they are coming out of the solution. Okay, we talk about one of the example. First of all, those are double displacement reaction. The cation, those two cations will switch to each other and making a correct new compounds. Okay, and when you write those compounds, you make sure the cation go first, anion go later. Okay, cation will go first, anion go later. Once you write the correct formulas, and then we're going to balance the equation to make the reaction correct, the equation correct. Next part, also we talk about what is the acid-base reactions. What is the acid-base reaction? And we know what is the acid. Acid is the one has the hydrogen at the beginning for the first compound. For the first, okay. And acid usually is anything that can donate or produce the hydrogen ions. Okay, so acid definitely is the electrolytes because they can produce the hydrogen ions in the water. Okay, so the hydrogen ions can transfer electricity. That's for sure. Okay, so this is the acid. For the base is the one containing hydroxide ions. Hydroxide ions. So those are all base. So in another word, base is also an electrolyte. They can also generate the cations and anions in the solution, which is can conduct electricity. So we talk about the base is anything that can donate or produce the hydroxide ions in the water, then this is the base. This is base. And then eventually, what is the acid-base reaction? It's just acid like this, HCl, base like sodium hydroxide. The acid-base reaction eventually actually is a double displacement reaction also. The hydrogen ion is going to replace the cations over here. So hydrogen ion and hydroxide ion, they're going to combine together to make a HOH. The HOH is not usually, we're not writing HOH. And HOH actually just the water. But when we write water, we write H2O, okay? But this is also the formula for the water, but usually we don't write like this, okay? So eventually, acid and base reaction, they are going to generate water. So this is the eventual reaction for acid and base reaction. This is to generate water. And another one compound is a salt. Okay. So this is the key for acid-base reaction. If you see something plus something to make a water, So this is in most of case, that's an acid-base reactions. That's acid-base reaction. Okay, so generally this is what we talked about the last time. So today we're going to talk about again for the precipitation reactions. Okay, yeah. So this reaction is what I wrote for you. And based on this, you know, okay, this is double displacement reaction, and we know one of this is a precipitate, and figure out which one is a precipitate. But the point is, if I giving your two random compound together, how come can you predict which one is the precipitate? Is there any rule to figure out which one is a precipitate? Right? Yeah. Otherwise, I mean, I give you the equation, you know which one is a precipitate. I say the one right as S over here, which means it's a solid. So that's a precipitate. But how can you predict which one is the precipitate? You don't know, right? Yeah. So this is what we're going to talk about today. Okay, first of all, we need to learn one of the knowledge. It's called the solubility. It's called the solubility. Well, solubility generally is talking about whether this compound is soluble or not. Whether it's soluble or not. So first, let's see, what is the soluble mean? Soluble, that means it's able to be dissolved. Soluble means it's able to be dissolved, which means when this guy dissolve in the water, they are going to become a solution. Okay, it will dissolve in the water and become a solution. They're going to dissolve in the water, become a solution, and then when we write the compounds, then we're going to add the aqueous over there. One of the example is just the sodium chloride, and we write AQ. So if this guy is soluble, then that means it's can be dissolved in the water, and then when you write this in the solution, you're gonna write AQ, which means this guy is able to dissolve in the water, or is aqueous, which means it's dissolving in the water. Okay, so that means it's soluble. Then compared to the soluble, there's another term, it's called the insoluble. Okay, so insoluble, that means it's not able to dissolve in the water. Insoluble, that means it's not able to be dissolved in the water. So if this guy is not able to dissolve in the water, then that means when those two reactions put together, they are going to become a precipitate, because they're not going to dissolve in the water, so they have to come out of the water. If it's coming out of water, and we call those solids as a precipitate. Okay, we call those solids as a precipitate, and then they are going to become a precipitate. PPT. Okay, so one of the example is silver chloride, that's a solid, and barium sulfate, solids, and also last time we talked about lead to iodine is also solids. Yeah. So not all the compound is able to be dissolved in the water. Only just some of those compounds, those are soluble, so they can dissolve in the water. So that is why today's job is there any rule that we can help us to tell the difference? So we just based on the formula, and we can figure out whether this compound is soluble or not soluble. Okay, so this is what we are going to talk about. Okay, just based on the formula to determine whether it's soluble or not. Well, I writing with this one is soluble, those are not soluble, but you don't know. I know because I already look at this for many times. Yeah, but you have no idea. Okay, so is there any rule so can help us just based on the formula to tell whether it's soluble or not? If it's soluble, then we know this guy have to dissolve in the water. If it's not soluble, we know when we have this as a product, this guy must be a precipitate is coming out of the solution. Does it make sense, right? Okay, so how to determine whether it is soluble or insoluble, this is what we're going to talk about, solubility. Okay, solubility. This is the rule. There's several rules for solubility. Okay, there are several rules for solubility. Well, of course, the rule is not including everything. Here, I just try to talk about the rule as simple as possible. And those rules is only talk about something that can be dissolved in the water. Okay, I only talk about there's something that can be dissolved in the water. Okay, so the rule number one is, okay, so if you see the 1A group metal, which ones? This is the alkaline metal. So if you see the compound containing the alkaline metal, which is lithium ions, sodium ions, potassium, rubidium, Sicilian. Okay, so if you see there's those ions in the formula, and it doesn't matter what kind of anion is at we will see a conclusion. This compound must be soluble. Must be soluble, which means they will dissolve in the water. Doesn't matter what kind of anion that combining the cations, they are all soluble. Okay, yeah. So if you see those rules, then generally you can exclude quite a lot of the compounds. Okay, so for example, we have a lithium chloride, right? We have sodium oxide and potassium fluoride, rubidium sulfate, or Sicilian phosphate. You see, those are all, this guy all have the first 1A group metal as the cation. So as long as those guy has if you see those compounds containing the cations, the first 1A group cation as the 1A group metal as a cation over there, then definitely this compound will be able to dissolve in the water. It's soluble. So those are all soluble. This is rule number one. Okay, so it's pretty straightforward, right? Just based on the formula, you can figure out which one is soluble. Okay, Rule number 2, and this is talk about, okay, let's talk about nitrate ions. So if you see the formula, if you have any of the cations and the plus nitrate ion, if you will have any of the cation and you plus nitrate ions, then those guys is soluble. Okay, those are definitely is soluble. Those guys is soluble. Okay, any of the cation plus nitrate, those are soluble. Those are the soluble. Okay. For example, if we have a lead to nitrate, lead to nitrate, silver nitrate, okay, potassium nitrate, or calcium nitrate. You see, as long as those guys are nitrates, those are all soluble. So those guys will all dissolve in the water. Those guys will all dissolve, be able to dissolve in the water. And usually, you see, the lead and the silver, for those two cations, most of the case, those are precipitate. They're not going to able to dissolve in water except nitrate. Okay, yeah. So doesn't matter what kind of cation you put, they are always soluble. So this is the 2 rules that we're going to talk about. There's another rules, but I'm not going to talk about because in the intro chemistry, we're not talking that much. Okay, we're not talking about that much. But I hope those 2 rules you can remember. It's pretty straightforward. If you see the formula has the 1A group metals over there, then those guys are soluble. If you see the formula containing nitrate, then definitely is also soluble. Okay. Okay, so here we're talking about those things that are soluble. Then how can we determine whether this compound is insoluble? How can I mean, if we don't have those, how can we determine that's insoluble? Does that mean besides those rules, the rest of the other compounds are all insoluble or soluble? Not exactly. Okay. So now this is what I'm going to give you supporting information. This is the last supporting information I'm going to give to you. It's called a solubility chart. Okay, solubility chart, which means you can base on the solubility, this chart, to determine whether this compound is soluble or not. And it will help you to predict the equation correctly. Okay, so this is why we need this. All right, so let's talk about how to use this solubility chart. Okay, yeah, if you look at the chart and front and the back, okay, front of the back. If you look at the second page, below the table, actually it's already telling you some of the solubility rules. Okay, solubility rules, but those rules are too much. I'm going to just show those 2 rules for you. Cation, first metal, no, sorry, 1A group, metal plus any of the compounds, any of the anion that's soluble, nitrate plus any of the cation is soluble. For the rest of the other formula, then if you look at it, how do you determine? Okay, so you look at the column. There's two columns shows over here. First one is Ni, second one is the cations. So for example, if you look at one of the compounds like silver chloride, okay? Silver chloride, this guy is made by silver and chloride, silver ion and chloride ion. So you first you look at the Ni. The Ni is the chloride. So the chloride is in the middle, is a little bit lower than the middle. And then you look at the chloride over here, and then the chloride plus silver ion, and see is there where the silver ion it is. Okay, so looks like the silver ion in this category, and then you see okay, I find a silver. So chloride plus silver, that's equal to low solubility or insoluble. Okay, so that means the silver chloride, this compound is insoluble. Okay, so this guy is insoluble. So insoluble means what? Means this guy, when you put the silver chloride in the water, they're not going to dissolve. Okay, or when we generate the silver chloride in the water, they should coming out of water. They are not going to be able to dissolve in the water, right? So that means when they coming as a product, they should be coming out of the water, which means they're making a precipitate. So when you see a product containing silver chloride there, you should write a silver chloride S instead of silver chloride AQ. The AQ means this solid is dissolving in the water, but that's not possible because this guy is insoluble. So instead, you should write silver chloride solids, and S means solids. S doesn't mean it's soluble. Okay, S means solids. So this guy is going to coming out of the solution. Okay, this guy is going to coming out of the solution. So that's a precipitate. PPT, which is a precipitate. Okay, yeah. So this is helping you to determine whether this compound is soluble or insoluble. Okay. Okay, so let's do some practice. I'm going to write some of the compounds, and then you're going to, but let's do one more practice. Okay, how about the calcium carbonate? Okay, well, calcium carbonate is made by calcium ions and the carbonate ions. Okay, so you're gonna see where is the carbonate category. Well, carbonate is not in the first page, that's in the second page. Okay, second page, then you see, okay, carbonate is in the middle. Okay, we have a sulfate carbonate over there, and then you see, okay, I found a carbonate. Next one is the calcium. Where is the calcium category? Well, in the first category is only say alkaline ions and hydrogen ions and ammonia ion. It's not say there's no show on the calcium. Well, that means that's going to be in the second category. Okay, if it's the calcium is not in the first category, that means it's in the second, which means it's any other cations. Calcium belong to any other cation. Okay, so that means the carbonate plus the calcium, that's any other cation, that means it's insoluble. Okay, so this guy is a precipitate, is coming out of the solution. That makes sense? Any questions? Okay, so this gives you a conclusion. Okay, the calcium carbonate is insoluble. So when this guy become a precipitate, then you're gonna write is a calcium carbonate, a precipitate. Okay, and then let's see one more. So how about calcium hydroxide? Okay, so we have a calcium hydroxide. Then what are we gonna do? Okay, so this guy is made by hydroxide and a calcium. So let's look at where is the hydroxide. Okay, hydroxide is still in the back. It's in the first row. And you see hydroxide plus calcium is the calcium in the first row. No, not exactly. Okay, which means the calcium will belong to any other cation. So hydroxide plus any other cation is insoluble again. So calcium hydroxide is still insoluble. That makes sense? Okay. All right, so let's just talk about some of the other compounds. Okay, so please figure out those following compounds, whether it's soluble or insoluble. Okay, so go ahead to figure out those following compounds, whether those are soluble or insoluble. Yeah. Did you say it again? I'm not sure.
What is reaction?
So if you see that's impossible to only have a cation or anion in the solution. If you see the anion in the solution, you have to have a cation.
What if you have compound plus one element? And at the end you have
Another compound elements.
so that element can be precipitate.
Yeah, elements can be precipitate, but we're not talking about those. Yeah, this is also another precipitate reaction, but we're not talking about it. I only just in the category double displacement reactions. Okay. Okay, so now you can, based on the solubility chart, you see, okay, chloride plus any other cations that's soluble. So magnesium is any other. So this guy is soluble, so that should be, this guy is able to dissolve in the water, so that's aqueous. Magnesium hydroxide, this one should be a precipitate. Okay, so this guy should be a precipitate, which means you should write S. And this guy is soluble. this guy, calcium chloride, is also soluble. Barium sulfate is a precipitate, and the barium hydroxide is soluble. Okay, so that is just based on the solubility chart, you can figure out whether it's soluble or insoluble. All right, so now once we understand that's solubility for the compound, then they give us a very good chance to predict reactions, to predict precipitation reactions. For example, we have silver nitrate. And this guy, you see, nitrate plus any of the cation is soluble. So this guy actually is a soluble solution. You can dissolve in the water. And Ag nitrate, the silver nitrate aqueous, that means we put the silver nitrate and dissolve in the water and making a solution. So this means it's a silver nitrate solution. Okay, silver nitrate solution and meet with another solution, which is sodium chloride solution. This is also a solution because the sodium ion plus any of the cation will be soluble. So this is one solution. This is another solution. And we put those two solutions together, then we see what happened. Well, again, we talk about one double, this is a ionic compound, and we have another ionic compound. Those two ionic compounds will making a double displacement reactions. So they're going to have a double displacement reaction. But at the point of one of them one of the product, they're going to making two new ionic compounds. But one of the compounds will become a insoluble, which means it's a precipitate. How can we determine which one is a precipitate? Which means how can we just based on those two can finish the whole equation? Okay, so here, this is the translation we're going to do. First, you know, this is a double displacement reaction, and we're going to base on the reactant to predict what is the correct formula for the product. And then we base on the given formula for the product to determine which one is still aqueous solution and the other one is a precipitate. Which one gonna be the precipitate and which one is still going to dissolve in the water. So this is the case we're going to do. And also this is the case for the practice for today. Let's take a break first. Bless you. Okay, so let's come back. Okay, so the next part is, okay, how do we determine if I give you the two solutions? I mean, not all the solution will have a precipitated reactions. You just mix those two random solutions together, may or may not have something happen. Okay, yeah. So here I'm giving you two solutions over here, and I'm telling you this is a precipitation reactions. And how do we write what is the product for those precipitation reaction, and which one is the precipitate? So this is what we're going to talk about. Okay, remember those precipitation reaction we're only talking about as a double displacement reactions. Okay, well, for some other type of reaction, they also has a precipitated reaction, but we're not talking about those. Here, the precipitation reaction we're talking about is only under the category of the double displacement reactions. So you know this must be a double displacement reaction. Then what happens here? And you know the cations and those two cations will replace to each other's, and making them together. Then so that means the silver ions is going to combine with the chloride ion, you see? And this sodium ion is going to combine with nitrate ion. So there's a two, we're going to making two new compounds, okay? So then you're going to think about, okay, silver ion and the chloride ion, what is the correct formula for the silver plus chloride? Well, then you need to know, okay, so the silver has one positive charge. You can find it in the common ion sheet. Nitrate has a -1 charge. Sodium is 1A group, so this guy is +1 charge. Chloride is -1 charge. Well, silver is combining with chloride. This guy is +1. This guy is -1. Okay, perfect. So we're going to just write silver and chloride because this guy is +1, this guy is -1. So those two match together perfectly. Okay, so this is one of the compounds for the product. And then they're going to plus another product, and which means is a sodium is combined with nitrate. Sodium is +1 charge. Nitrate is -1 charge. +1 -1, perfect. Okay, so the result will be, okay, so here there's a mistake. I see people do this. They say the nitrate go first and the sodium later. So they're going to just write NO3 Na. And you said you're going to, I mean, those two will replace together. So I'm going to just write like this. No, okay, no, this is not a correct formula. Because in this case, you put nitrate, which is anion first, and put the cation later. We never write compound like this. We write compound, we always put sodium, which is the cation, go first, and anion later. So when you write the compound, you need to make sure the compound write in the correct order, which is cation go first and anion later. Sodium is a cation and nitrate is anion. So that's going to be the correct formula, sodium nitrate. Okay, so now you write those two products. Which product will be the precipitate? Then what are you going to do? Okay, solubility chart will help you. Or you can just base solubility rule. You can learn something, right? And we talk about sodium. Any sodium plus any of the cation, sodium plus any of the anion will be soluble, right? Because sodium is in 1A metal, it's 1A group metal. Sodium plus any of the anion, that's soluble. So this guy definitely is soluble. Then that means this guy should be insoluble. Is that right? And then you can double check with the solubility chart. Okay, chloride plus silver, it gives is a low solubility or insoluble. So this guy definitely is insoluble, and then they're going to have a precipitate is coming out. Okay, so sodium chloride, this guy is a precipitate, is coming out. They're not going to be dissolved in the water. So there's no AgClAq. There's no AgClAq. Impossible to have this because this guy is not going to dissolve in the water. So you shouldn't write like this. Instead, they're going to coming out of the solution. So that's a solid, which means this is a precipitate. Okay, so that is a precipitate, but this one is a solution. Okay, so here, this one, then the equation should be correct. Well, you can double check whether this is balanced or not. You can see, okay, we have a 1 Ag, 1 silver, 1 silver, 1 sodium, 1 sodium, 1 nitrate, 1 nitrate, 1 chloride, 1 chloride. So this one is perfect. Okay, yeah. And this one is easy, but not always gonna be like this. Okay. So let's look at the next practice, next example. So we have the barium chloride. This is a solution, and it's going to mix with another solution, which is the sodium sulfate. This is also a solution. So now, what those product? Two solution, mix them together. This is a double displacement reactions. How do we predict the other two? Okay, again, when you think about the cation and the cation will replace to each others. So the barium will going to replace the silver ion, not a silver 2, not an Na2, okay? So barium, we're going to replace the silver ion. Oh, sorry, the sodium ion. The sodium, we're going to replace the barium ions. Okay, so then what should we write? Barium, again, you need to make sure we're going to write the correct formula. Write the correct formula. Barium, what is the charge for the barium? This guy has 2+. What is charge for the chloride? minus, right? 1 minus. So that is why we have this barium BaCl2 over here. And the charge for the sodium, that's +1, sulfate is -2. So the barium is going to combine with sulfate. This is a 2 plus, this is 2 minus. So what is the correct formula? Just write BaSO4, right? Don't write Ba2SO42, okay? This is not correct, okay? We try to make this as a simplified ratio. So the barium will combine with sulfate, and this is one of the compounds. The other one, okay, sodium is going to combine with chloride. Well, a lot of people here, they make a mistake. Okay, they can easily write Na2Cl2. They just write like this because you said we're going to replace everything with this, right? So we have Na2 over here, and this is Cl2. So we should write Na2Cl2 over here. Well, have you ever seen, what is this called? Sodium chloride. Have you ever seen sodium chloride writing like this? No, right? So what is the correct formula for the sodium chloride? It's just a sodium and a chloride. There's no 2 underneath of this. So that is why I'm saying you're gonna write the correct formula, okay? Because when the sodium ion combined with chloride ion, they have their own correct formula. You need to make sure that the formula is correct. But when you write like this, you may ask, wait, if you write like this equation is not balanced, right? Yeah, of course it's not balanced. You can balance this later. You don't have to balance at the same time, okay? So you write the formula first, make sure the formula are correct, then you go balance the equations, okay? So now you're going to balance this equation and make sure you put the sulfate as just combined together as a polyatomic ion because we have a sulfate in the reactant. We also have a sulfate in the product. You don't have to count how many sulfur it has, how many oxygen it has, okay? So for this equation, how do we balance? We try to make this equation. So to balance this equation, we try to have something that has multiple elements and has the highest number. So I'm just assume this guy is a 1. So I'm looking for sodium sulfate. And I assume this guy has 1, then that means we're gonna have a 2 sodium and a 1 sulfate on the right side. So so I should write 2 over here to make a 2 sodium, and I should have 1 over here to make a 1 sulfate. Okay, yeah. So now we have the coefficient for all the products. Now you can see we have a 1 barium, so and also 2 chloride. So we should write 1 over here. So we have 1 barium, 2 chloride. Then the equation is balanced. Well, the very important is double displacement reaction is pretty easy to be balanced. Okay, you just write the symbol numbers, then they should be very easily to be balanced. But they have to under a requirement is you need to write the correct formula. If you're not writing the correct formula, then you have no idea how to balance. Okay, so very, very important. So in the future, if you write a formula, the double displacement reaction, you feel very hard, you have a really hard time to balance this equation. That means you have most of the chance you have a product wrong. The formula of the product is not correct. All right, so now once you have those 2 products and also you balance this equation, what are you gonna do? You're going to make sure which one is the precipitate. Okay, which one is the precipitate? Well, again, if you look at sodium ions plus any of the anion, that's soluble. So This guy definitely is a soluble. And then we need to double check whether barium sulfate is a precipitate or not. So you can go ahead to look at the sulfates, and you see the barium is in the first row. Sulfate plus barium, that means it's a low solubility or insoluble. So this guy will be a precipitate. So this one is a precipitate. That's it. Does it make sense? Okay, yeah. So this is talking about the precipitation reactions. And if we have the two reactants, how do we predict which one is the correct precipitate, and how do we balance these equations? Okay, how do we balance the equation? Again, we're going to do the practice for today on this part. Okay, so I think that we talk about the precipitation reaction. We talk about the acid-base reaction. Again, acid-base reaction, that eventually is going to form water plus another ionic compound. So generally, this is what happens. So if we have the multiple choices, and you want you to determine which one is acid-base reactions, you just need to see, okay, do we have acid over there? Do we have a base over there? Are those combined together to making water? So definitely that's gonna be the acid-base reaction. Okay, acid-base reaction. So this is what we're gonna do. So next one is called a gas forming reaction. There's another equation reaction is called a gas forming reaction. Well, gas forming reaction is generally is talking about after the reaction will generate a gas. There's a bubbles or gas coming out of the reaction. And those are all called the gas forming reactions. Okay, those are all called the gas forming reactions. I'm not sure whether you did one of the, did you, okay. If you want to clean the sink, okay, in your apartment or your house, okay, if you want to clean sink, the best practice, you can easy to get, you have the baking soda, and then you put quite a lot amount of the baking soda in the sink, and then you're going to just add a white vinegar over there. And then you can mix those two together and flush it with water in the sink. Then it will clean your sink. Okay, so but during this process, there's a lot of bubbles or gas is coming out. Baking soda plus vinegar will generate bubbles. And this is one of the gas forming reactions because it's a forming gas. Okay, so let's see what happened for the baking soda. So the baking soda is sodium carbonate. That's a baking soda, sodium carbonate. And this guy is a solids, right? The baking soda is solids. We're not going to dissolve in the water. And then you're going to add in the vinegar. The vinegar is another acid. Vinegar is an acid, but this is a pretty weak acid. And this acid is called acetic acid. CH3COOH. So this is a vinegar, or we call it acetic acid. Acetic acid actually dissolve in the water, it become a vinegar. Okay, so this is called acetic acid, and this is also a vinegar. So baking soda, this is a baking soda. Baking soda plus vinegar, they're going to generate, well, again, this is double displacement reaction. Here there's a hydrogen. There's a hydrogen will combine with, they're going to making acetic acid, sodium acetate, and plus carbonic acid. Okay, so this is sodium acetate, and this is a carbonic acid. Well, if you look at it here, then you will see, okay, this guy is a solution. It will dissolve in the water. And carbonic acid is acid. It's not a gas. Well, carbonic acid is really, really unstable. This guy is really, really unstable. So once you have the carbonic acid generated, it will decompose to the other two things. It will become water and the plus CO2 gas. So the CO2 is a gas that's coming out of the solutions. Okay, coming out of the solution. So that is the gas forming reaction. Once the baking soda mixed with the vinegar, they have a lot of bubbles coming out. The bubbles actually is the CO2. Okay, yeah. Just like once you're a lot of the carbonic acid. So once you drink the soft drink, like the Pepsi, Coke, Spirit, no, it's called Sprite, right? Sprite and the root beer, doesn't matter what kind of things. Okay, so once you're open, what you can hear, right? And that is because the CO2 is coming out. Okay. So most of those soft drink actually containing carbonic acid. So those are acidic solutions. So once you drink, actually it's kind of like a damage your teeth. Okay, yeah, the more soft drink you drink, I mean the more damage to your teeth. Okay, because your teeth actually is a calcium phosphate. Okay, so you probably didn't feel that too much, but actually the carbonic acid will going to dissolve part of your teeth. Although you cannot see that much, but the more you drink, you will see the carbon your teeth will be has a low dense because a lot of the teeth will be dissolved. Okay, yeah. So this is one of the case. So that's why a lot of people don't recommend you drink too much. You can drink, but don't drink too much. That's it. Okay. Yeah. For your health. Okay. So this is one of the gas forming reactions. And if you see, there's another. If you're putting the sodium solids, just the pure sodium metals, and you dump those sodium metals in the water, then you will see gas is coming out. They're going to generate a sodium hydroxide and hydrogen gases. So this is also another gas forming reactions. The hydrogen gas will coming out. Oh, sorry, not the S, should be gas. Okay, hydrogen gas is coming out and the sodium hydroxide is going to dissolve in the water. So I haven't balanced this equation. Okay, I need to balance this equation. That's one. Wait, one here. Okay. Oh, so 2, 2, 2, and 1. Okay, so that is balanced. Okay, so as long as you see gas forming reaction, that means that when you have the reaction, the product, one of the product is a gas. It's coming out of the solution, and this all called gas forming reactions. Those are all called the gas forming reaction. Okay, yeah. All right, so the last reaction we're going to talk about is called the redox reaction. I don't expect you to remember what exactly is a redox. I'm just going to showing. Okay, so there's some kind of reaction. It's called the redox reaction. Have you heard the redox before? What exactly is a redox based on your knowledge?
To gain electrons.
Yes, yeah. This one is complicated. So I don't want to talk about the gain electron, losing electrons. Well, eventually redox reaction is gain electron, losing electrons. The redox actually is what you call it is a reduction plus oxidation. Reduction plus oxidation. So those are short for reduction and oxidation. So you say redox, that means reduction plus oxidation. That's a redox reactions. Okay, so redox reaction is complicated, and sometimes this is the most hard part for the chemical reactions. It's called a redox reaction. It's pretty hard. I don't want you to expect you to know why this reaction is a redox reaction. I just want you to recognize what kind of reaction could be the redox reaction. Okay, yeah. So let me just give you the conclusion. All combustion reaction are redox reaction. And remember, we talk about combustion reaction. For example, we have methane. It's going to react with oxygen gases, and then they're going to form CO2 plus water, right? This is what we talk about combustion. Combustion reaction is organic matter reacting with oxygen, to form CO2 and water. So that's a combustion reaction. And you see the oxygen over here is going to oxidize the methane over here. So this is a redox reaction. Okay, this is a redox reaction. And you can see in the future, if you see the product, the reactant containing oxygen, doesn't matter what kind of reaction, as long as it's containing oxygen, it definitely is a redox reaction. Okay, that's for sure. It's a redox reaction. As long as they have oxygen in the reactant, that's for sure is a redox reaction. Okay. As long as the oxygen is in the reactant, this reaction is a redox reaction. Yeah. So if you want to understand what exactly redox reaction, you have to come to the Chem 1 class, and then we will talk about more. And then if you come to the Chem 2 class, and we talk about that even deeper. Okay, yeah. So the redox reaction, now I just hope you can recognize, okay, this equation is a redox reaction because we have oxygen precipitate in this reactant. The other reaction is all single displacement reaction. Or single displacement reactions are redox reaction. Or single, so for example, A plus B, C to form AC plus B, okay? So now we have an element, one of the element plus a compound. And this is going to be the ionic compound. And they're going to form another new element plus new ionic compound. You see? So why the reason this guy is or redox reaction is because they have elements in join in the reactions. So in the future, another conclusion is if you see elements in the reactant, elements in the reaction, as long as you see the elements in the reaction, then definitely this reaction is redox reaction. Yeah, if you see the elements, you see the first one, the combustion reaction, oxygen is also elements. If you see there's elements in the reactions, then definitely for sure this is a redox reaction. This is for sure is a redox reaction. Okay, yeah. All right. So then the other one is called O double displacement. O double displacement reactions are not redox reaction. Okay, all the double displacement reaction are not redox reaction. Okay, so the first two we talk about what kind of things is redox reaction. The last one we talk about which one is not. Okay, double displacement are not redox reaction. You can think about this is AB plus CD, and then they're going to form AD plus CB. So this is a compound, compound 1, and this is compound 2. And this is a compound, new compound 1, and new compound 2. Any elements over there? No elements. So this guy definitely for sure is not a redox reaction. Okay, yeah, no elements. No pure elements involved in this reaction. So this guy is not a redox reaction. Okay, so now those are, if you remember those three, that's enough. Okay, that's enough for now. That's enough for now. Well, so I'm going to telling you one of the story, and this story is the mistake that I made, and this is a redox reaction, and okay, it's really bad for me. Okay, really bad for me. So before I move to Wichita, I need to clean my house and sell the house, right? Yeah, in Stillwater, Oklahoma. Yeah. So I try to clean the toilet, but the toilets, there's a lot of some solids. I mean, it's not that easy to clean, right? Yeah. So I bought 2 products over there. One I bought is the hydrochloric acid, I mean, that's called works. Have you heard the product is called works? Never heard of? The works containing HCl, like 5% of HCl up there, right? Okay. And also I bought another product. You already know, you should know this. This is sodium chloride, sodium hypochlorite, which is bleach. Okay, so I also bought the bleach. So this guy containing sodium hypochlorite. Okay, sodium hypochlorite. And then I try to, at the beginning, I just try to using HCl to clean this, but it looks like it's not working well. And then I'm gonna think about, okay, maybe I can just add those two together and make the clean it. That's faster, right? I don't have to using the work, clean and flush, and then using the bleach, work it again. Why? Why don't I just put those two together and make this faster? Then horrible things coming out. At that time, I didn't realize, okay, although I'm a chemist teacher, but I didn't realize HCl and sodium hypochlorite, then once they are mixed with water, they are going to generate the chlorine gases. And also the sodium chloride solution. Okay, sorry. This is, they're going to produce water. I'm not going to balance this. I'm just let you know, those two combined together will generate the chlorine gases. Do you know what is the chlorine gases? Chlorine gases is very corrosive, actually. Yeah, it's very corrosive. In the World War I, okay, so the people exploded the bomb containing the chlorine gases. Actually, it's damaged quite a lot of people on the battlefield. Okay, yeah. So the chlorine gases. So once you intake the chlorine gases, you will choke quite a lot. Okay, so because this guy is, those are not pleasant, the gases. Just to put them together, immediately you're gonna have a lot of the chlorine gases in my bathroom. Okay, a lot. So I need to take a lot, I mean, just a half day to vent all the chlorine gases out. Okay, I didn't realize at the beginning, but later when I check online, I see, okay, so those two combined together, they do have the chlorine gases. And you see chlorine is elements, and these elements present in these reactions. So this is definitely is a redox reactions. Okay, it's definitely is a redox reaction. So never put the works and the bleach together to clean things. Okay, this is the lesson that I learned, and then you don't have to experience that again. Okay, yeah. All right. So this is the chemical reactions. Okay, let me just review what we learned. Okay, today we talk about what is the solubility. Okay, what is the solubility? And if you can base on the solubility chart and based on the formula to figure out which one is soluble, which one is insoluble. Soluble means this guy will dissolve in the water, become aqueous phase. Insoluble, that means it will be a solid and coming out of the solution, which is a precipitate. Okay, and then we talk about if we have two solutions, mix them together, how do we predict which is the correct formula for the product, and how do we predict which one is the precipitate? Okay. And then we also talk about two more different reaction. One is called the gas forming reaction. Any reaction, if it's generated gases, then that is a gas forming reaction. And we also talk about what is a redox reaction. As long as you have elements in the reactant, or product. As long as you have elements in the reaction, chemical reactions, then definitely for sure, this is the redox reaction. Okay, this is for sure is the redox reaction. And the double displacement reaction are not redox reaction. And if you talk about this reaction, and you will see this guy is a redox reaction, and this is a gas forming reactions. Okay, yeah. So this is pretty much what we talked today. Let's take a break, and then we will do the practice. And today's practice is just going to predict the precipitation reaction and finish the whole precipitation reaction, and then predict which one is the precipitate. Okay, yeah. So let's take a break, and then we will work on this.